Your MRI can't read your mind, but it can watch you think. Stay with me. This is stranger than it sounds. Lie inside a hospital MRI. Picture your childhood bedroom, and the magnet wrapped around your head can watch which parts of your brain start working. Not your thoughts, not the image in your head, but the blood feeding the cells that are doing the thinking. That's the trick. The scanner doesn't see ideas, it sees oxygen. And once you understand that one sentence, everything else about fMRI, about lie detection stories in the news, about those Berkeley videos where researchers reconstructed a movie from a brain scan, all of it falls into place. So here's what we're going to do. I'll show you how the scanner turns your own blood into a built-in contrast agent. Then I'll show you the experiment where researchers played movies to people and pulled the movies back out. Then I'll show you where this breaks, why it's not admissible in court, and why the only reason it works at all is that you cooperate. Because the surprising thing about reading a mind with magnets isn't that scientists can do it, it's how much has to go right for them to pull it off. Let's go inside the machine.
Your brain is the hungriest organ you own. 2% of your body weight, 20% of your oxygen budget. And when a patch of brain starts working harder, say the piece that lights up when you see a face, it pulls in fresh blood within about 2 seconds. Now, there are 2 kinds of hemoglobin in that blood. Oxygenated, the molecule carrying oxygen to the cell, and deoxygenated, the one on its way back out, having dropped off its cargo. And here's the thing. Those 2 molecules respond to magnets differently. Oxygenated hemoglobin is basically invisible to the magnet. Deoxygenated hemoglobin is slightly magnetic. It distorts the scanner's signal in a very specific, measurable way. Flip the ratio, and the scanner sees it. According to PubMed, Ogawa and colleagues at Bell Labs published this in 1990. They figured out something wild. Right under any active brain region, the ratio of those 2 blood types shifts every time the cells fire. They called it the bold signal. Blood oxygen level dependent. Every fMRI scan you've ever heard of runs on that acronym. So when a researcher says, this region lit up when the subject... Okay, so the scanner sees patches of your brain working harder. Big deal, right? That's not reading thoughts. That's reading traffic. Here's where it gets spooky. According to PubMed, in 2011, a team at Berkeley, led by Jack Gallant, did something that still reads like science fiction. They put people inside an fMRI scanner and showed them hours of movie trailers. And yes, the subjects watched those clips with their heads clamped still, which is as uncomfortable as it sounds. While they watched, the scanner recorded which little cubes of their visual cortex were firing. Thousands of tiny voxels, each one a few millimeters wide. Then they trained a computer model. Every time a certain shape or motion appeared on screen, certain voxels activated in a certain pattern. Curved line, this cluster. Fast motion to the left, that cluster. Once the model was trained, they ran a new experiment. Show the subject a brand new movie clip. Record the brain activity. Feed it to the computer.
Now here's the part the headlines skipped. According to PubMed, the Tang team tested their decoder on subjects who deliberately resisted, who counted backwards from 100 by sevens, or named animals silently, or just thought about something else. The decoder fell apart. It couldn't reconstruct anything meaningful. The machine needs you to cooperate. During the hours of training, yes, but also during the actual scan. Opt out, and there's nothing to read. That's why fMRI is not admissible as a lie detector in US federal court. It's why every paper in this field ends with pages on consent. And it's why in real hospitals today, the actual clinical use of fMRI is much simpler and much less spooky. Before brain surgery, a neurosurgeon needs to know exactly where the patient's language and motor areas live, because those areas are not in the same spot in every skull. They put the patient in an fMRI, ask them to tap fingers, speak silently, read sentences. The scanner maps the critical regions. The surgeon cuts around them. That's what this technology does for a living. Not mind reading, map making. So here's my question for you. If an fMRI could reconstruct your last dream, with your permission, would you let it? Yes or no? Drop it in the comments. And if you want the full physics of how this scanner sees anything at all, I've got a deep dive on the main channel. Link is in the pinned comment.